Hi guys, we are starting to a new chapter, which is electromagnetism, or a new, actually, area of physics. So we were talking about vibration and waves, and in the first semester we mainly talk about mechanics, but now we are moving on to a next area, which is electromagnetism. And today we're going to talk about properties of charges. So electricity and magnetism, it basically talks about mainly electricity and magnetism, but what does that include? So you can watch this video. It basically anything that uses electricity, and that basically includes television, radios, motors. Motors are not just using electricity, they also use magnetism. High energy accelerators, same way, they mainly use magnetism. And your computer is basically anything that you are using right now. Most of the things are electrical. So it was basically a revolution for the industry, actually, once they have discovered the electricity and magnetism and how we use them. And it wasn't actually too long ago. It was around like 200 years ago or 300 years ago. So before that, we didn't have electricity in our world. But now, think about it, we have almost everything working with electricity. So it has a really, really big impact in our lives. All right, so, but it's not just basically working with anything that uses electricity or our electronic devices, but in atomic level, formations of the matters are actually happening with electrically. All right, even the springs, when they are basically compress stretch, the reason that they are able to compress stretch in the atomic level, it's due to electric forces. And today's main topic is going to be electrostatics. So you can watch the videos, but you can actually bend the water with the plastic. But how do you do so? Or you can even use this dome to basically scatter your hairs like that. So what is the reason for that? The reason for that is basically they are electrified or electrically charged. So charges are basically able to attract and repel each other. And that repulsion and attraction is going to have an electric force. All right, so we're going to show it with Fe. And the reason for that electric force is charge. And what is the source of a charge? It is basically going to have two sources. One of them is going to be positive charges, which is possessed by protons. And we're also going to have negative charges. And the reason for the negative charge is electrons. All right, so that's why electric forces or electricity is going to basically go in the atomic level, because everything that we know of is made out of protons and electrons. So that means everything actually has this positive and negative charges. Then what does that mean? Everything must be charged, right? Then why don't we able to actually see this picture in our daily lives? Or why don't we see this again in our daily lives? Why don't we just run the water and it bends? So since we have charged protons and electrons and everything, then we expect things to shock each other. But nothing is shocking each other. What is the reason for that? Because to be able to get charge, you shouldn't just have protons and electrons. It's not enough to be charged to have electrons and protons, but the rule is the number that you have. So one number should be more than the other. So in neutral objects, we have positive and negative are the same. So the number of positive, which is protons and electrons, they are the same. So if they are the same, then they are not charged. So there's no shocking or anything. But once you actually put those two objects together, well, it's not going to work for every object, but certain materials, once they are basically put together, then they are going to actually exchange the charges in between them. Then what's going to become, this guy, in this case the balloon, is going to have more negative charges, then this is going to become negatively charged, and this guy is going to have more positive charges, so that means this is going to be positively charged. All right, so basically to get charged, it's not enough to have protons and electrons, but to be able to get charged, you need to have more protons or more electrons in the object, so that you can say that it is charged object. All right, another some information: rubber rod and glass rod. So glass is basically positively charged. It tends to get positively charged, and rubber rod is basically tends to get negatively charged. And of course, there are some properties of those charges. They don't really act randomly. If you have two same sign charges, it doesn't matter negative or positive. If they have the same sign, they're going to repel each other. And if they have the opposite sign, they're going to attract each other. And the key thing about this, the attraction and repulsion, the force in between them are going to be equal due to the action reaction, which is Newton's third law. So you need to be careful with that. The forces in between them are equal. And another extra information, the contact lenses are basically using this electric force in between your tear, in your tears, and then basically connecting electrically. So positive, negative basically attract each other. So the second property is charge is conserved, which means the total charge in the system is not going to be destroyed or created. They can only be transferred. So let's say you have 4 electrons and 4 protons in the hair, and then you have, let's say again, 4 electrons and 4 protons in the balloon. So once you are actually putting those two into contact, what is going to become? This 4 electrons, actually not all of them maybe, but let's say 3 of them will move to the balloon. So 3 electrons. So if 3 moves to the balloon, then you will only have 1 electron left in the hair, and you're going to have 7 electrons now. Then what happened in this case? Even if you don't touch the protons, which actually protons in reality don't move, the ones that they move are the electrons. So what happens? You have 7 electrons and 4 protons in the balloon. So what does that mean? Balloon is negatively charged. And in the hair, you have 4 protons and 1 electron. So you have 3 extra protons in this case. So the hair is positively charged. And what was the first rule? Opposite charges attract each other. So now you have negative charge, positive charge. What do? They attract one another. But what didn't we do? We did not add extra electrons or protons to the system. We still have 7 plus 1, 8 electrons, and 4 plus 4, 8 protons in the system, which was the initial condition. So total charge is not changing. They are just transferred from one material to the other. All right, so this is the second law of electric charges, or second property of electric charges. Electric charge is conserved. And you can actually look at those and then solve those on your own. And the third property of electric charge is quantized. What does that mean? It's like number of people. So if you ask the number of people in a room, you don't expect answer like 1.5 people, right? Because we don't count people in halves, right? So just like this, charge is also not counted with random numbers. You cannot just have any number that you want as a charge. Charges are going to come in packets. So just like human, the number of human is basically packets. If you consider that as a packet, they come with ones, right? But or if you want to put it a little bit differently, let's say you're going to have $1,000, but you only have $20, right? Then you will not be able to have $23. If I ask you to give me $23, you cannot give me $23 because you can only give monies in the multiples of 20s because you only have $20, right? So just like that, charges can also can't be in any number. They are not going to be in 20s though. They're going to be in a little bit different number. They're going to be in 1.6 times 10 to the power of negative 9s. Yeah, I know, negative 19s. I know this is a weird number, but this is, why do we use this number? Because just like money, if you want to consider the money, you cannot have, let's say just we are using the bills, you cannot have half a dollar, right? So the smallest dollar bill that you have is $1. So if you want to give up money to someone, you cannot have $0.75 because they are coming in $1. The smallest money that you have is $1. So this for the electric charges is a charge of an electron or charge of a proton, because they have the same amount of charge. And this charge is, again, this guy. So that's why the smallest charge that you can have is charge of one electron or one proton. And charge of this guy is 1.6 times 10 to the power of negative 19. And how do we calculate the total charge of an object? We basically count how many extra protons or electrons we have and multiply it with the charge of one of them, and then that is going to tell us the total charge of the material. All right, so charge is quantized. They don't come in any numbers. They must come in multiples of this weird number. All right, so if total charge of an object is 3.2 nanocoulombs, then what is the number of excessive amount of protons or electrons? So first we need to convert nanocoulombs to coulombs, and we need to remember N stands for nano, and it represents 10 to the power of negative 9. So that means the total charge that we have is 3.2 times 10 to the power of negative 9 coulombs. And since the sign is positive, then we can say that this is a positive, this is a proton, or it has extra protons. And charge of one proton is this much, and total charge that you have is this much. Then how many do you have in it? Then a way for us to do this, you basically divide this 3.2 times 10 to the power of negative 9 to the charge of 1, which is 1.6 times 10 to the power of negative 19. And once you divide it, you will find that you have basically 20 billions of protons in your system. And the next one is you rub your hair with the balloon, and then your hair ends up with extra 4 billions of extra protons. And then what is the charge on the balloon? So we need to consider conservation of charge. Since your hair has extra 4 billions of proton, then that means the charge of balloon is negative extra 4 billion electrons. But what will be the charge? So since charge of one of them is this guy, and if you have 4 billions of them, then what will be the charge? Basically, simple equation, number of one charge of 1 times the number of the extra electrons, which is 4 billion, times 10 to 1.6 times 10 to the power negative 19. So it is going to basically give you negative 6.4 times 10 to the power negative 10 coulombs, or negative 64 nanocoulombs. And what is the difference in between the electron and proton? So if you look at it, the charges are exactly the same. Neutron has no charge, but the difference in between protons and electron is basically the mass. Mass of an electron is almost 1,000 times less than the proton, and neutron and proton have almost the same mass. Not the same though. All right, what is insulator and conductor? Insulator is the material that has free electrons. Conductors. So conductors are having free electrons, so they are able to move. And if they're able to move, basically they are able to conduct the electricity. But if we don't have a free electron in the object, then we call them insulators, and they are not able to transfer the electricity from one material from one point to another. And human body is a conductor, and most of the touchpads are basically using this property. So if you try to use an insulator to actually use the touchpads, you're not going to be able to do that, because most of the touchpads are they're using the conductors, so they're working electrically. All right, so that is basically